Hello everyone, my name is Luka Gerzic, as he said. I'm a consultant for last few years in Belgrade and in Europe, and I have around 17 years of working experience. Today we are going to talk about web developers' common system security mistakes from the system engineer point of view. But before my talk, I would like to take 1 minute and dedicate my presentation to a very good friend who's passed away this year in April. He was a very good friend of mine, and he will be missed. So this is a little bit about myself. I started to use computers from the 87 year, from the Atari. Plus after that with the BBS systems and some mail exchange with the Blue Wave network. Anyone here used BBSs? Few. I'm very glad to see that. After that, I started using Slackware Linux, which is still my favorite distribution, but unfortunately, because of the packages and everything, I moved to Debian because of the projects involved. But I still maintain some of the servers based on the Slackware today, and they're very, very stable. This is today's agenda, and we are going to talk about some issues that I have encountered. I have some 30 minutes to talk on all these subjects, so I'll try to be brief as much as I can. I'm open for discussion after the presentation, and of course afterwards outside. Okay. So first thing is this is the I'm really truly inspired by Mitch's quote. Since due to these mistakes, I make a living, not once regarding the guns and the alcohol, of course. But all this became even worse after the cloud and cloud implementations of the application. So, starting seriously issues that we have and that I have encountered so far is first with the rockstar developer attitudes, with the guys that started to implement all of these things completely wrong. For example, developing their own security methods and encryption protocols and all that stuff, which was a nightmare and created a lot of issues. Also, the attitude they had is that they thought that nobody is going to attack our application is not really important, and but they never realized that 98% of attacks in web applications is automated, and that bots and scripts and everything else is trying to break into the application to gather data or resources or whatever they can from your application. The thing is that in the last few years there is a very big boom of the outsourcing companies in Serbia, especially, that are trying to do projects for the European Union or the United States. And really, they're trying to get as much as developers as they can, and that sometimes create really big issues. So in 7 out of 10 projects, this is what I have encountered so far. So first thing is that they started to hire developers which are not trained on the platform they are working on. Like, for example, they hire PHP developers from the Windows platform to work on the Linux and open source projects. They had not a single security aspect training whatsoever. They don't know how to validate input properly, and they don't even think about that. They are not using any encryption in projects whatsoever. Started to include third-party services into their projects without really realizing who is controlling those projects and where is the code and stuff like that. And for example, also the open source projects are regularly included in other projects, and I'm going to talk about that a little bit later. Many times they forget to remove some sensitive data and push the code to the GitHub. So basically, you could get the administrative user for the application from the GitHub. The favorite command of some of the developers is allow everybody to do everything inside web folder, because application doesn't work without that. And of course, using single SSH keys for everything, including private projects, including everything, and every possible environment you can think of, they are using single key. And then laptops get stolen. So the last thing is maybe the worst one, is that they neglected system infrastructure, cybersecurity completely, because they don't have good relations with the system engineers or system security guys, or they even don't have them. So for example, here are some real life examples. The first one is, let's allow upload of images in our applications, but don't worry that images are verified, so they have extension JPEG. But then allow users to rename those files, right? So what you do, you just upload myfile.jpg, which is your PHP code, and then rename that to PHP on the server. So you'll get uploaded your code to the server. The second one is, don't worry, we are protected. They need to log in to get access to our data. But then they forget that they are allowing same username and password. Same password as the username, or 3-character passwords. And the last one, which is my favorite, and I usually get really silent after I hear something like that. My project is not working, and I Googled some solution, and some guy said that probably a firewall feature. So I copy-pasted this command, and now everything is working. So basically that came after they called me because they got hacked. So this is something that they're encountering mostly, more or less. So how it all begins with the development process, of course. This is more or less a typical process of development. Your mileage may vary. There are different modern versions or some older ones, but more or less it's the de facto standard. So can you tell me where do you start with security?
Design requirements.
No? Awesome, you're good, because most of them, they start with penetration testing after the application is done. So they call some security expert, which they say, oh, we're finished with the application, and can you test this application, for some problems, issues? And when they realize that they need to rewrite half of the application because of bad design and examples, they start screaming, and usually management decide not to do it. So they go with the application which is flawed, and they start patching it. Basically, security requirements need to be put on the start with the requirements of the project. These are some of the principles of secure coding that I'm trying to explain to the developers and their team leaders when we start talking about security. It's very important to try to help all teams involved in development process, because when you're done and you're finished with your application, it's too late, simply too late. Also, why this, for example, multi-layered security models reduce impact on individual security bypasses. You can imagine, for example, Spartans, which had shields, each and every one of them, not one shield for the whole army. That's the basic principle that you should try to implement inside your application, to try to protect each individual part of your application. So, this is usual imagination of the infrastructure in some cases with the developers. They think, okay, we have our network, private network, and we have some server which is somewhere, and our customers, and some internet in between. They don't think about the whole infrastructure, and they don't think about what is everything that they have inside their infrastructure. So basically, that creates a lot of problems, because project architecture can look something like this. You can have multiple servers in the multiple locations, even data centers, synced across the whole internet. And of course, you can try to create some kind of redundancy, for example, where you have master-slave replication, or you have your virtual servers, which are based on some virtual platform, which of course you can share with other users, including the network. So this creates a lot of problems, because data can be crossing between servers, between the network, between these data centers, and what developers usually forget is encryption. So these are typical examples of man in the middle, which is grabbing the plain text passwords for the HTTP access. It's very simple, it looks very easy to read, and you should always try to remember that you have, for example, your MySQL replication in plain text. And if you use it across the internet or across the network, you should try always to encrypt it, regarding, of course, the other plain text protocols. This is the same thing, but with MySQL and Mongo. At the top, you can see the query and data from the database. All that can be seen very easily with a TCP dump. Not big of an issue for the man in the middle. That's because you're not using encryption. So when we talk about the encryption, first, if you hear, I wrote this encryption algorithm, it's proprietary and it's very, very fast, and our data is protected with that, you run. You don't look back if you hear something like that. Always try to use some open source encryption protocols which are thoroughly tested by the community. And always think that proprietary or secret algorithms are a big failure in advance. I would recommend that you try to use in your project S-script or PBKDF2 or bcrypt. Reason being is that these encryption protocols are designed with protection in mind. Basically, bcrypt is based on Blobfish and it's resistant to rainbow table attacks, while the S-script is designed to be very hardware costly if someone tries to brute force it, especially on the memory side. And by the way, consider that anything with less than 128 bits is considered non-secure, and that would mean passwords less than 22K sensitive alphanumeric characters. And when we talk about passwords, how do you encrypt passwords in your database? Do you encrypt passwords in your database? All right, someone know? Okay. Well, first of all, you should try to create your own key. For example, you can have multiple keys, and then put some cipher and encryption protocol around your passwords and put that data inside. So how does that look? Well, this is an example of your user password in the database. You can have multiple key. keys for your different environments. For example, if you have developer environment, production environment, this application, that application, doesn't matter. You can first prefix it with your own key, then you can use different ciphers and encrypted passwords. You should also remember that you need to do the same thing about the tokens, meaning that you need to worry about the resetting password stuff, permanent logins, and everything else. And on top of that, try to expire user passwords after some time, and as well tokens. So how about the login response? Fail login. Does your application have active or passive approach to brute forcing of the username and passwords? Does anyone have active approach? All right. The active approach would be that you log IPs and you log number of failed attempts. You create a profile or some kind of other metrics to detect when someone is trying to break into your application, because your application is 24 hours a day available on the internet, and there are some evil scripts which are trying to break in. All right? So also remember that this needs to be implemented globally, meaning that if you have a different page for resetting password or a different page for logging to some other parts of the application, you need to have this on all those pages, meaning globally. This is what happened recently due to brute forcing and some small bugs. You all heard about the iCloud. They guessed the email address and simply started to brute force it. So if your application is holding data of the users on the internet and you don't have any active protection for your login, this could happen. Maybe the most important thing when you're developing your application is about the input validation. The input validation, you can treat it as any code that receives input is driven by that input. It's very important to realize that 24/7 your application can be accessed from some kind of script or bot or whatever. Never ever assume that only legit users will be using your application. And now let's move to the basic housekeeping. This is more or less a work of a tired developer trying to fix something on the production server late at night, and you see how many garbage he left. For example, he left a generic name of the dump file for the complete site. There are scripts that are searching for such files on the website. And this is the example that we have picked up in the logs, what they are searching for. So if you left your dump file on the web, the first thing is that some kind of script is going to pick that up. And the second thing is your backup scripts will also pick that up. And you forget about that, you delete the file, but then you do a restore and you get those files back. So keep in mind about good housekeeping of your root web folder. There is also history files, info PHP, which is usually a PHP info function inside of it, or some configurations, and not to mention the permissions of the file, which are pretty fucked up. So basic housekeeping is something that you really need to take care of. Don't leave that. How about PHP functions? Does anyone here remove unnecessary PHP functions from the PHP ini file? Oh, two. Great, guys. There are many PHP functions that are not necessary for your regular application work. For example, exec or system functions are really not necessary. You can do everything through your modules or some other add-ons or whatever. So don't leave them enabled on your system. Disable all unnecessary functions and you are going to see why. The one that I already told you about is PHP info was enabled to leak the vulnerability about SSL keys. It was patched recently, but many people leave PHP info on the servers because they are like to have testing or get information about the server or whatever. Disable those, don't leave them on your production. Regarding database security, oh boy, how many times I have seen root user using database. You cannot imagine how many times. No splitting of user privileges whatsoever. So that's completely wrong, and you should always set the proper DB specific privileges for each application and never ever use global ones. For example, if your application is just outputting some data to the website, to the user, that application needs only user that has read rights, nothing else. Don't give it everything else. Try to segment the security and you will be thankful later. Of course, don't use generic username and passwords as well. Try to create some creativity into that and limit each database user by DIP. Of course, no wildcards and stuff like that. I know that these things can create a lot of pain for developers because of the creation of a large amount of users and keeping track of all the IPs and everything, but it's a good thing. And now, how about the open source? Should you use open source in your application? Simple answer is yes. Many people are using OpenCart or some billboards or whatever. Or they're using just parts of those applications. For example, WordPress is very popular these days and they're just using parts of the code and implementing that in the application. And what happens is that they forgot about that. They implemented some kind of code into their website and the project, passes some time, and we have vulnerability publicly available for those applications. If you don't patch your software for those vulnerabilities, someone will find through the scripts or bots or whatever and own your application. This is really common case when they say, okay, I implemented that, let's move on. It's secure, I don't care, our application is closed source. Yes, your application is closed source, but it uses open source projects. The next thing is regarding the application error handling. So, does your application fails open or fails closed? What information are you disclosing when an application is forced to some mode you're not expecting? For example, this old lady is using application as she thinks she should use it. Did you think about that? No, nobody put something to protect her from doing that. So the outcome of your application should never be publicly available. Try to catch your errors and never ever display system information, because people are trying to break your application to get data they need or get whatever they can. So let's talk about owning a box in 5 easy steps. Not so easy but for example, in the first line, some script will find your SQL injection. After it finds your SQL injection vulnerability, it's going to use the same, you see this is the PHP exec function, which I talked about, and you forgot to disable that. it will create a script in some folder on your web root. And after that, it's going to download some C code. And you see today or yesterday how people are good in breaking things. So after that, they compile it, or even they don't need to compile, they can just transfer the binary code and own your box. This is the way, if of course there are some conditions, but more or less this is the example how things get worse. So, some words of advice. Validate all input. Place limits on resources and time usage, and try to split administration from your production. Always try to protect it. Use encryption in your projects for everything that you can. Special care and handling on the uploads is very important, because handling of uploads is very difficult and it really needs your special attention to, because uploading files is a way to upload malicious code to your server. And did I mention to validate input? Security is a teamwork, and it's really important that you collaborate with all your teams when you're building an application. It really doesn't matter if the system engineer or developer is creating very good security practice when someone left the door open, or in this case, forget to put the fence. And with that, I thank you for your time.
I need to ask a question. Isn't it actually a very bad practice to encrypt passwords? It should be hashed, long-way hashed, and nobody should be able to plain text your password from the database ever.
This is one way. I was talking about encryption, which is one way. So
So basically, because okay, so that's terminology. Because when people say decryption, it's basically meant for encryption and decryption, but hashing is like one way. Okay.
your application will not decrypt this password. You will never know user's password.
Definitely, yeah, hashing.
Yeah.
Okay.
Any other questions? Okay. Thank you very much.